All right, so let's go ahead and start talking about technical stuff. Maybe the first thing that I will show you here, we will take a look at the topology I will be using during this demonstration. Um, it's not really, there's really not going to be a lot of devices involved here. The focus is going to be our access point that is connected to one of the switches, and I will be trying to deploy .1x authentication on this switch. So instead of authenticating our access point using MAB, as you could potentially do, depending on your security policy, we will be trying to deploy .1x. And there is going to be a couple of implications or just caveats related to this configuration. So this is what is going to be the subject of this session. I want to show you how this deployment can be performed and what kind of potential problems you may have when dealing with this configuration. Okay, so we're going to have a couple of switches in this topology here. CAT2 is where our access point is connected to. So this is going to be our access point, and this is FO22 on this device. Then CAT2 is going to be connected to another switch, CAT4, which is where we have our WLC. So WLC is configured as a trunk. The port connected to WLC is configured as a trunk. We will not be testing the data plane in this case. The focus is going to be just the network access part. So it's going to be more of a switch configuration and then the configuration on the identity services engine. Not really a lot of stuff here. Also configuration on the WLC. So this is the physical topology. Now logically the devices are going to be placed in the same VLAN. So the management interface of WLC, then identity services engine, now our access point. All those devices are going to be in the same VLAN, VLAN 100. We will also have our switch, Catalyst 2. I'm going to create an SVI, which is going to be also part of this VLAN. So ICE is 150, and WLC is 250. Access point, we will assign an IP address to the access point using DHCP, and Catalyst 2 is going to be 120. So once again, the focus here is going to be this point on Catalyst 2, FO22. I want to show you how to configure it for .1x. Okay, so let's, first thing I'm going to show you here, let's quickly configure our ICE and prepare the switch so they can talk through radius. Let's go ahead and do this first. So I have a ICE administration GUI opened, and I will basically add our Catalyst switch to the network devices so they can talk for radius. We will then configure our switch and then move on to WLC. Okay, so let's go on administration and then network access devices. Then I should be able to add our switch. So at this point, I just want to add a client so they can talk to each other. Let's give it a couple of seconds. Okay, so just a name and an IP address. And let's go for iPexpert as the key. Whenever you, at least on our devices here, Whenever you open up the session, the administration session, and you're going for those policies for the first time, it takes a couple of seconds more than if I were to open it up once again from that point. But it's still not that bad. So this is going to be catalyst to 10.1.1. 1.1 is going to be an IP address. And then I'm going to specify the key here, iPexpert. And let's prepare our switch for that 1X. So this is going to be catalyst 2. Let's take a look at the configuration here. So I'm going to need an SDI because I want to put the switch to be part of the same VLAN. I will be using this SDI for communication with ICE. And we actually have an SDI for VLAN 100. So I will now start configuring AAA services. So first thing, I want to enable AAA in the model. We're supposed to enable the framework. And then 2 method lists. One is going to be for authentication, where I will say that I want to use that 1X for authentication. And then possibly we can also add the network authorization, where network authorization is going to be useful whenever you want to download an access list and you want to apply it on the port. Now in our case, I'm going to configure these 2 elements because this is part of a regular .1x configuration for wired .1x. But as I said in the beginning of this session here, I will not be actually showing you we will not be testing the actual policy, and we will just try to figure out if access point is able to connect to the network, and if it is, what was the method that we used for authentication. Because at some point I will be actually showing you also a combination of .1x and map, actually map and .1x, but we're going to start with just .1x. So authentication for .1x, a default method list, and we will be using radius for authentication. So authorization, once again, not really needed in this case, but part of a regular configuration. I'm going to put it here as well. And then the radius server, which is 10.1.1.150. iPexpert was the key I have configured on ICE. This device runs 12.255 SE7. In the newer versions of iOS 15 and above, there is a newer syntax you could use to define your radius servers or TACX Plus servers, which is radius space server command. And this is how you could also enable communication over IPv6. But in our case, this is IPv4, and this is the older version of iOS, so I need to use this old radius dash server syntax. Okay, so at this point I will basically test. I want to make sure that the devices can talk for radius. And the simplest way we can do this is to use the test command, test AAA, where I will say that the group, I want to test my radius servers. I can put some random credentials like ABC, ABC, and use the legacy option. And this is what we want to see here. You either want to see that the authentication was accepted, which would mean that this user is defined in the radius database. In our case, it is not. So I used fake credentials, but since I received access reject message from the radius server, I know that the devices, my client and my server, that they can communicate. So we are good at this point. Okay, before I start configuring that 1X on the switch, we will need one more thing on the identity services engine, which is going to be the user I will use for that 1X authentication. So the logic here is going to be that on WLC, on the LAN controller, this is an example of a unified wireless communication. which means that our access point is going to be getting the configuration from WLC. So on WLC, this is where I will be configuring my .1x credentials, and those are supposed to match what I will put on ICE in the local database, because I will be using local database of ICE for authentication. So at this point, I want to add user to the local database. So identity management, identities, and the users. And let's call it .1x user. And password is going to be iPexpert. Now, normally you could also think about associating this user with a group, with a user group, which could be then used in your policies, like in the authorization policy, as one of your conditions. But in this case, I didn't really care, so I'm going to leave this field blank. The only thing that I care is that I have a user in the database. Now, if we go under the authentication policy, which you will see here, and also in the authorization policy, these are pretty much the default settings of ICE. So, almost default settings of ICE. We still have 3 rules, but the conditions here, we match both wired and wireless connections for MAC authentication bypass, and then for .1x. In our case, I can simply modify this configuration. Let's say, because we will be doing wired .1x, so I can remove this component, and do the same for MAB. At some point, I will be also using MAB, so I want to make sure this is all in sync. So at this point, this is pretty much the. Okay, I removed it. And this is pretty much the default configuration. You match wired MAC authentication bypass sessions and .1x sessions. Now for MAB, we will be authenticating those connections using the endpoint database, versus for .1x, we will be using the internal users database. So this is where I added my .1x user. So this is authentication policy. When authentication is successful, we will then proceed to the authorization policy. So what do we have in the authorization policy? We've got 3 rules. One is for blacklisted wireless devices. The other one is for IP phones. And we've got a default rule that says we will deny access. So normally what you would do here, you would create a separate rule for your access points. Like typically this would be a rule that matches devices that were profiled as access points, and you would assign a certain policy, so-called authorization profile, which is your access list, your VLAN, maybe a switch port macro, that kind of stuff. Now, if this was .1x, you would probably match .1x and the group of profiled access points and apply the policy. Now in our case, I don't really care about the policy which is going to be applied. The only thing I do care is that access point, once it authenticates, is going to be given access to the network. So I will modify the default rule where I will say that the profile returned is permit access, which is an empty access accept radius message. So it says that radius is okay with the connecting device or user. It wants to give access, allow access to the network. So this is the authorization rule that is going to be matched in our case. We want to open access for the connecting device. And this covers the configuration, at least for .1x, on Identity Services Engine. Now let's go ahead and configure the switch. Okay, so what do I need on the switch here? This is going to be a basic .1x configuration, which means that I need to enable the framework globally via the .1x system authentication control command. And then on my interface here, so once again, FO22 is connected to the access point. This is where I will be configuring my .1x interface settings. Authentication command, and first thing I will say that the host mode is actually a single host. This is the default setting, which means that we expect only a single device in the data plane that is connecting to the port. But once again, this setting is the default. Then the example I'm gonna show you is gonna be this is gonna be the closed mode deployment. So I will not be using the open authentication feature and restricting the pre-authentication access using so-called pre-authentication access list, which means that access is only gonna be given to the connecting device when it successfully authenticates. There is no pre-authentication access, so there is no access for the device before it authenticates. All the traffic prior to authentication, successful authentication, is blocked. Authentication order, we will use flexible authentication in this example because at some point I will also show you how you can use MAB, the open access for the access point. So I will say that first thing we will be trying to authenticate our access point via .1x and then via MAB, so MAC authentication bypass. Then I will say that the priority is going to be for .1x and then MAB, which means that if for some reasons the device was authenticated via MAB and at some point later .1x becomes available, like the supplicant was installed, for example, on the PC, .1x authentication is going to preempt. We should see another authentication, but this time using .1x. But we will talk about it later when we get to this, to the point where I will be showing you how to combine the two methods. So this is the configuration we have so far. You always want to make sure that the port mode is set to access because you will not be able to see the authentication commands. You will not be able to configure any of the authentication commands on this port. So mode access was before. On the interface, I configured just 2 authentication commands. We still need a couple more. Authentication, port control. This is where I will enable .1x. And this is how I can enable .1x when I use the auto option. The default is for first authorized, which means that you will not be authenticating the device or a user via .1x. I will not enable this option now. We will configure all other settings required for what I want to show you here. Then we're going to test our access point to WLC communication. So before .1x enabled on the port, before .1x is enabled on the port, and only then I'm going to enable .1x. But once again, let me first finish the remaining configuration we will need here for .1x on this interface. So at some point I will want to use MAP. I want to enable it on the MAC authentication bypass. I want to enable it on this port. And I also want to tune the timers. So MAP is going to kick in when .1x times out, or in our case also when .1x authentication fails, which is hopefully not going to be the case unless I mismatch the credentials. Timeout, I'm going to say, is going to be just 5 seconds. TX period is 5 seconds, which means that .1x with the default configuration of 3 times 4 attempts and the timer of 5 seconds, this is going to mean that MAB should kick in about 15 seconds from when .1x authentication started. If the device doesn't authenticate within 15 seconds by .1x, this is when we should see the MAB kicks in. And the last command here, .1x PAE authenticator, which tells the switch that for this particular port, it should act as an authenticator in the .1x process. So this is what we always want to have enabled on the switch when we want to use .1x. Okay, so once again, at this point, I will not be enabling the feature. We still need one more command on the port to enable .1x. We will now focus on the wireless part. So .1x is disabled at this point, and I will be trying to configure my access point, or just WLC, so access point can obtain an IP address and hunt the controller and join the controller so it obtains the configuration. So let's go ahead and take a look at the controller. So I said the WLC is 10.1.1.250, and I also have a PC in the same VLAN. So I will be using this PC to access the WLC for administration. HTTPS admin iPexpert 123. And the WLC is pre-configured for this session. I have defined just one wireless network, which is our security, our management wireless LAN. Then I also defined a DHCP pool for our access point. So basically, WLC is going to act as a DHCP server in this management VLAN. You see the IP address of the DHCP server is the same as the IP address of the management interface of WLC, which means that WLC is supposed to assign addresses from its locally defined DHCP pool. And once again, we have just one wireless LAN defined, which is the management network. So not really much configuration on the WLC. Maybe now let's quickly talk about the process or about things we expect to see to happen between us. So what's going to happen between the access point and the WLC. So the key thing to understand here for the wireless part is that access point is going to need to obtain an IP address from a DHCP server so it can detect and join the WLC. So this is the unified network. Maybe let's go to the previous slide here. Which means that once again the configuration and potentially the image, the iOS image, is going to be obtained, is going to be downloaded from the WLC through the so-called CAPWeb connection. So CAPWeb, or Control and Provisioning of Wireless Access Points protocol, this is the main protocol that is being used between the WLC and the access point. And the way it works is that when an access point obtains its IP address via DHCP, this is going to be the management interface of the access point. It is going to try to build the CAPWeb tunnel through the wired network with the controller. So this is going to be the CAPWeb tunnel, which is used for both for the control plane and also for the data plane, when the access point is going to be doing the conversion between the radio frequency and the, actually this is going to be actually the controller that is going to be doing this conversion in the mode that we are running here in our network, which is centrally bridged mode. So this is going to mean that the device that bridges the wireless into wired and vice versa is going to be the controller. So access point is going to be simply sending the data packets from the wireless clients as long as they want to communicate with the devices on the wired side. It is going to be sending those frames inside of a CAPWeb tunnel to the controller. WLC is going to decapsulate the frame, encapsulate it to the Ethernet, and send it back via the trunk to the appropriate VLAN based on the wireless LAN SSID found in the frame. So the key thing to understand here is that this CAPWeb connection must be always built between the access point and WLC. And this CAPWeb tunnel, it runs over UDP. I believe this is going to be 5 to 46 and 5 to 47 as the port numbers. Let's open up a document I still wanted to show you for this demonstration. So from the main documentation page, we will go down under wireless, and we will take a look at wireless LAN controllers, the standalone ones, 2500 series. And let's open up a configuration guide for 7.2, which is the version that is being now used on the CCIE labs. We will take a look at, I think this is going to be chapter 8, which is controlling lightweight access points. And let me quickly look for UDP keyword. It says guidelines and limitations. Make sure that CAPWeb is enabled. Okay, so CAPWeb uses 5 to 46 and 5 to 47 UDP. Now in this document here, in the same section, chapter 8, you can also find information of how you can enable that 1X for access points. Because once the CAPWeb tunnel is built, now our expectation here is that we will then configure that 1X profile for access points. So our credentials, username, and a password. And this information is going to be then sent for the CAPWeb connection down to the access point. So it knows what credentials it is supposed to use for that 1X. And this is also going to enable the supplicant on the access point. So in the same document here, now there should be a section for that 1X. I believe that this is going to be configuring authentication for access points. It says, excuse me, prerequisites. And then it says go to the global configuration and use this option, that 1X authentication checkbox. So there's really not going to be a lot of steps on the controller that you need to take to enable this feature, but you can use this document just in case you forgot about the configuration. I will be showing you those steps on the WLC, so we will discuss them in just a couple of seconds. Let me also show you one more document. Well, this is obviously a security session, and apart from configuring that 1X authentication on the switches for access points, there is a couple of other things you can enable for wireless security, and most of those options you're going to find under this link here, chapter 6, configuring security solutions. So we can find information like about IP in general, then access lists, wireless access lists, management frame protection, rogue devices, the detection, then classification, Cisco IDS. So a lot of security related feature for wireless. You can find them here along with the configuration for both the GUI and the command line. Okay, but let's go back to the .1x for access points. So this time we're going to connect to the. Are you still able to hear me and see the video? Because someone said that someone asks if the connection is lost. Okay, so most people says it's good, so it could be potentially a problem on your side. Because on my window here, I see that the session is streamed. Okay, so let's go back to the WLC. And we will now, maybe first thing before we will configure .1x, let's make sure that access point at this point was able to join the controller. I'm going to open up a command line for both the access point and the WLC. And it's going to be a little bit faster if I use the command line on the controller to figure out if the access point joined, found the controller or not. You can use the show access point, show AP summary command. So we see that the access point called with this name, which is my access point, joined the WLC. We can take a look at the leases. We see that it got an IP address assigned, and we should also see that this wireless network was sent down to the access point. So ideally, we should be able to see that it broadcasts this SSID. So this is what happens before .1x was enabled on this interface. So now we're going to change it. We're going to enable .1x on the interface, and we will see what's going to happen. So no, I didn't do any additional configuration on the WLC. If I take a look at the access point configuration, let's say show run, and I want to specifically look at this section. It has some credential for .1x. Let's go to the WLC, and under wireless here, global configuration, this is where we will be configuring our .1x for access points. I'm going to disable this section. I want to have the .1x disabled at this point. We will apply. And let's also go to the all access point section, and let's take a look at this individual access point under the credentials tab. This is disabled. I'm going to explain you those sections in just a minute. So hopefully this configuration was pushed down to the access point, which it was. I will now tell. Okay, actually I don't need to reboot the access point because the supplicant was disabled. Access point doesn't have the credentials. It will not be able to successfully authenticate via .1x. So let's go ahead and enable .1x on the switch here. Authentication, port control, auto, which means that I want to ask my Radius server if it is okay with allowing this device connecting to access the network. It says .1x failed. Now let's give it a couple of seconds. Apparently it may have the supplicant enabled. Let's take a look at the access point. And it says going back to the discovery mode because CapWeb timed out. So it looks like it lost the connection to the controller, now which is fine in this case. Let's bounce the port. Let's shut it down. But this is going to cause an access point to reboot, which is fine, because at this point it doesn't have the credentials, that one X credentials in the configuration. This applicant was disabled. When I power it back up again and it reboots, it's going to take a minute or so. What we should see here on this interface is that the switch is going to be first trying to authenticate the access point using .1x based on our authentication order. Then when .1x times out, it is going to be trying to fall back to MAC authentication bypass. And now if this authentication is successful or not depends on our endpoint database configuration, right? Because we will be still consulting our ICE, trying to figure out if this device, if this MAC address of the access point is in our database, and if it is, we will authenticate it. To verify the endpoint database, you can go under Administration and Identities, and this is going to be this is going to be endpoint database. Endpoint, and endpoint database is blank. Based on our, another authentication, but a policy authentication. Based on the configuration of our authentication policy, when the endpoint database is blank, it means that, so this is going to be this part. If user is not found, we're going to reject the authentication. Okay, so let's go back to this identity management section. And one thing that I did, that I want to change here for the user, I just realized that the password I configured for the user is not going to meet the requirements on the WLC. I specified iPexpert. I want to change it. iPexpert 123. So once again, there is no access point added to our endpoint database. It is going to fail MAC authentication, and then after the quiet period elapses, that 1X is going to start over, then map, and so on and so forth. So there's going to be a loop. The switch is going to enter into a loop into the authentication loop, trying to authenticate the access point, but it is going to keep failing. So this is what we should see now. And now obviously, since authentication keeps failing, so it says starting at 1X, nothing, no .1X frames are received from the access point because this applicant is disabled. It fails over from .1X. You see in about 15 seconds, it took about 15-16 seconds to fail over from .1X to MAB. And it says that MAB also fails. So if I say do show authentication session for interface FO22, okay, now it started over. So it says running .1X. After 15 seconds, we are trying MAB, and MAB fails. So it says that both failed over, and the authorization failed. So obviously at this point, when I take a look at the access point here, it gives me a message saying that it cannot even obtain an IP address, because the port, we are running closed mode, which means that we are also blocking the HCP packets. So on WLC, show AP summary, we see that we lost our access point. So the problem we run into here is that when you first enable .1x authentication on the port, and .1x is not configured with the appropriate credentials, it is never gonna join the controller and obtain the configuration. So there is a couple of different scenarios you may actually have for .1x authentication for access point. One is gonna be when, so the simplest solution to the problem we have here is basically to first thing disable .1x. So no .1x on the switches, and then when there is no .1x configured on the switch, you can basically connect your access point, then you can configure your WLC for .1x, so access point can download this configuration from the controller, and then you can enable .1x on the switch, so this is when you don't run .1x on the switch to begin with. This is going to be this is your option. This is what you can do to enable the feature. So first thing, you want to disable it. You want to connect access point. It downloads the configuration, and then you re-enable .1x, or maybe if you didn't have .1x enabled, you basically enable it. Then the second case is when you have .1x already configured and you don't want to mess with your switches. So .1x is on the switches. And here what you can do is going to actually depend on the .1x deployment model or just the deployment phase that you have selected. There is going to be a difference when you run low impact versus what you can do when you run closed mode. So with low impact mode, the configuration is going to be pretty straightforward, because the only thing you have to do to support .1x for access points is going to be to modify the pre-authentication access list. So we want to add anything that is needed for an access point to join the WLC and download the configuration, which is going to be DHCP, CAPWeb, and optionally DNS, depending on how you're hunting the controller. Because there's a couple of different methods that access points use to find the controller, and one of those methods is by using DNS. So DHCP, CAPWeb, and optional DNS, this is something you would add to the pre-authentication access list. Then for closed mode, we will have two options. One is going to be to use the LWAPP command. What is going to be the actual command here? Let's go back to chapter 8, configuring authentication for access points, and somewhere in the prerequisite section, this is the command I was looking for, the LWAP AP.1x username. So we would use this command to hardcode the .1x credentials directly on the access point. Then access point is supposed to authenticate using .1x and be able to join the controller once the port is open for the access point. Then the last option you could potentially use is going to be to first enable MAB on the port connected to the access point, but leave the priority for that one X. So let's go ahead and take a look at this, those different options. One I already showed you. Actually, I will show you when I configure that one X on the WLC. So in our case, that one X was not enabled. I could configure that one X on the controller over here, and when I now, so maybe let's first disable that one X. Pretty quick. I want to show you this in action. So on the switch port, I will say authentication, port control, force, authorized, which means don't ask radius for to figure out if the connecting device should be authenticated or not. Just allow all packets from the connecting device. And then what you would have to do on the controller device would be to go under, you have two places where you can enable that one X on the WLC. One is under wireless access points, global configuration, and this is not going to be this section, login credentials. Login credentials, this is for the console management access. When you want to get management access to the console port, authentication for the connecting user, we want to use this section, supplicant credentials for that one X. So username, password, confirm, and this setting here under global configuration is going to apply to all access points, those that already joined the controller and those that will join the WLC in the future. So I could specify my credentials here, or when my access point rejoins, which happened several seconds ago, I can configure those credentials for this individual access point. And whenever you configure them in both places, in the global configuration and for the individual access point, those credentials specified for the individual device will take precedence. So our user was .1x user, and password was iPexpert123. Okay, so let's see if this configuration is going to be downloaded by our access point. Show ran section LWAP. So you can see that those credentials were pushed by the WLC down to the access point. So at this point, when I re-enable .1x, it's gonna take a while for to start this applicant on the access point, but at some point we should see here that it is going to be able to authenticate. So let's give it a couple of seconds. Now let's take a look at the switch here. It says initially that .1x fails. Do show. Let's maybe do this. Let's say do clear authentication sessions. Okay, so I cleared the authentication .1x process on all ports, including FO22. Do show authentication session FO22, and now we see that the device successfully authenticated via .1x, and it was also successfully authorized. You could also quickly take a look at the operations log on ICE. So we should see an entry in green that is going to tell us that that one X user was successfully authenticated. And under authentications, okay, so this is going to be that entry. It says the username, the MAC, the user was authentication, a profile return was permit access. And permit access is basically, once again, access accept sent by radius. Okay, so we will now I will now try to show you the second case when that one X is enabled on the port, was not configured by a WLC with that one X credentials previously, so prior to enabling authentication. This should run interface FO22. So once again, authentication is on. Authentication is on. On the controller, using the GUI, I'm gonna disable those credentials. Let's see if the access point took this change, which it did. So we will now shut the port for just a second. No shut. Okay, lost power. So it is gonna now reboot. And those credentials manually on the access point. So this is gonna be this first solution for a situation when that one X is enabled on the switch, but our access point never talked to the controller before. So the low impact, this is something that we will not be looking at during this session. We're going to focus on the okay, so this guy is booting up. Let's go to the WLC, all access points. At some point we should see we lose this device from the all APs section. Global configuration, and that one X is disabled, and we will lose it. Comes back up. It is not configured with that one X credentials. It is going to fail authentication and never be able to find the controller. Okay, so let me log in here. And on the switch, I can easily confirm that. So the first solution here for the closed mode on the access point itself, from the privileged mode, use the lweb command with the ap.1x arguments. Username is going to be .1x user, and password is going to be iPexpert123. Show run section. Once I issued this command, it enabled this applicant. So if we now clear authentication sessions, we see that that one X was now successful. Maybe let's do this from the controller. So all access points, credentials, remove, apply. And we will now focus on the second option I wanted to show you, which is going to be authenticating our lab. We're going to proceed to the authorization policy as usually on our identity services engine, which looks like that. Two rules that we will never match, and the default rule that says permit access. So this is gonna mean that access is gonna be granted for the device that was authenticated. Set the priority for that one X. It is gonna mean that when the access point downloads the credentials from the controller, it is gonna re-authenticate using .1x. So MAC authentication bypass, the problem with this method is that it is obviously not that secure as .1x. Change MAC address to be the address of the access point, and assuming that even if profiling was enabled on ICE, and the policy uses the profile, access point profile as one of the conditions, you can still spoof this information. It is going to be technically harder to achieve, but it's still possible. So your laptop may be configured for your access points, but you will be connecting with your laptop. So this is the problem with MAB, and actually this is the problem for any type of authentication you may break. You want to be as specific as possible with your policies, with your authorization profiles. So what it means is that when you're building your policies on ICE, anything else that access point may need. Also, the VLAN should be restricted to, protect, to give the highest level of protection. Then for phones, you wanna give access to TFTP, anything else that a phone may have, may need to have, and block anything else. So this is something that you would want to do in the first place. So this policy is gonna open access for CapWeb and DHCP. And then once it authenticates via .1x again, you could have a separate rule in the policy that is gonna catch those connections and possibly extend the access for the device authenticated via .1x. So to give more access via map. Okay, so show run section LWeb. Do show authentication session interface. 22. Okay, so let's clear the session now. We're gonna fail over to MAB. Now let's wait for an access point to lose the connection with the WLC. Show APE summary. So let the CapWeb tunnel times out. So the switch is again blocking configuration on the switch, we see the order is still .1x and map. The priority is .1x and map. So I'm going to leave this those options because this is what is going to be enough to test this configuration. You could technically swap map with .1x. Okay, so it lost the connection to the controller, which we can confirm on WLC. Let's now take a look at the switch once again. Let's clear the session once again. Okay, at some point, I may either enable the access point again, or we may give it a couple of seconds. And at some point, we should see that it will stop trying to authenticate via .1x. It will fall back to so it no longer obtains an IP address. Okay, let's shut the interface. Then let's no shut. And let's now go to ICE. So over here, I want to add an entry for my access point. Which is this MAC. I'm going to use this syntax. And maybe let's take a look once again at our policies. So to recap, what we should see now is that instead of being authenticated via .1x initially, where our access point map authentication is going to hit this rule, which is permit access. So it says authorization succeeded. It failed over. And access point is going to join in a couple of seconds. It is going to join the WLC. So I can quickly go to my WLC and configure it with, let's say, this time global credentials. .1x user. Point finally finds the controller. We should see that this configuration is going to be pushed to the access point, which it actually was. Show run section. which we gave to .1x, this is like when you're kind of like enable preemption. You say that when the stronger authentication method becomes available, you're going to preempt the current authentication and try to re-authenticate the device using this newer method. And this is from the WLC. So this is what we see now in the show authentication interface output. From iPexpert, you can visit that on YouTube. On basically look at our blog. We're also available on Facebook and Twitter. Information about some news, promotions, and a lot of other stuff. You can find it all here. Reach me at piotrk@ipexpert.com. Thank you very much for attending this session, and have a great rest of the day. If you have any questions now, we can